Hello, everyone, and welcome to Circuit Stream's Introduction to HoloLens 2 workshop. Thank you, everyone, for joining us today. It's a super exciting workshop. Can't wait to get you all excited with it as well. Now, before I do continue on, I want to make sure that you can all hear me and see me through a quick AV check. Can you please let me know in the chat box there? Can you hear me and see me? I see yes, loud and clear. Wonderful. Thank you so much for letting me know. Now, a few housekeeping things here. As you can see, there is a chat box to the right there. Feel free to chat amongst yourselves, toss in your LinkedIn profiles to network, ask questions freely. We're more than happy to help answer those for you. Now, beside the chat, there is another tab there called the Questions tab. If you have any questions for us, we do have a team backstage ready to answer those questions. Please toss in your questions in that Questions tab. It's easier for us to keep track of what hasn't been answered. And at the very end of this presentation, when we do have our Q&A session, we'll be sure to get through as many as we can. Now, beside the Questions tab, there is also a Polls tab there. I will be tossing in some polls throughout this workshop and webinar just to gauge the experience of the audience, and then we'll move forward from there. But I always do like to see where everyone is currently tuning in from. So please let me know in the chat there, where are you currently located and where are you tuning in from to watch this workshop? I myself am located in Calgary in Canada. That's where our headquarters are. But I do see a lot of Americans here from Seattle, Rhode Island, some Canadians, Montreal, Poland, Austria, Romania. What else do we have? USA, Indiana, Italy, India. So people from all over the world again. Thank you all for joining us. Now, for those of you who are located abroad, this workshop and webinar will be recorded. So if you have to go to bed, if you have to wake up for work, dinner, whatever it may be, don't worry. We will send this recording out to everyone who had registered for the workshop, and you will get that, if not at the end of day today, sometime tomorrow. Now, I will be taking about 20 minutes or so to introduce you all to who we are and what we do here at Circuit Stream, as well as a little bit about the HoloLens 2 before we dive into deeper HoloLens 2 information, learning hand gestures for authoring, how to think about the design of the HoloLens 2, and navigating inside Unity. So just to get you all, a little familiar with the HoloLens 2 and a little taste of it, I will drop a video here introducing you to the Microsoft HoloLens 2, and then we'll kick things off. Ooh, gives me the shivers. I hope you guys all enjoyed that. Give you a little taste of the HoloLens 2 and what you can expect with it. But again, I do have a bunch of my team members in the background here. You'll see Kyle sometimes in the chat answering some questions as well. My colleague Dayan and our instructors and developers answering technical questions. So let's get going there. My name is Stefan, and I'm the course lead here at Circuit Stream. I have over 5 years of experience in the tech industry, working with learning management systems, business integration platforms, travel IT tech, and now in virtual reality and augmented reality. A little icebreaker and fun fact about myself: I was a member of Water Polo Canada and trained with the 2008 Beijing Olympic team. Didn't go to the Olympics, but still a great experience nonetheless. Today, I will be joined by our colleague, Eric Carter. Eric is our principal VR AR designer here at Circuit Stream. He has over 15 years of design experience and most notably worked with Microsoft and Oculus. He was the one who actually developed the little hummingbird for the HoloLens. So, super excited to have him here and really an honor. Fun fact about Eric: he was a blue ribbon winner in junior steer riding rodeo. So I'm sure he'd love to talk about that if anyone's interested in chatting more. I will also be joined by our great colleague, Nakisa Donnelly. Nakisa is one of our instructors here at Circuit Stream and an AR/VR developer. She's a HoloLens and Magic Leap professional, and a fun fact about her: she's occasionally part of a circus. So anyone interested in circus activities, give her a shout. She's more than happy to talk about that as well. Now, a little bit about us here at Circuit Stream. So Circuit Stream was founded in 2015 when everyone was on the hype train for building VR and AR apps. We noticed a gap in actually helping people learn how to develop and manage these applications. And since 2015, we've taught over 30,000 people how to develop, manage, and implement this technology, either for personal interest or at their workplaces there. Now, Circuit Stream is also a Unity certified training partner. Training partners are approved based on their expertise, focus on quality education, and commitment to providing the highest level of training available. Circuit Stream is also an official channel partner with Unity to deliver training and application development services in the architecture, engineering and construction, automotive, transportation, and manufacturing markets. For those of you who may join us for any of our courses and programs, it is a Unity recognized certificate that everyone gets, and we'll dive more into that shortly. Now, there's 3 things that we really do here at Circuit Stream, and the first is education and training. So these are some of the happy, customers and companies that we've had the pleasure to teach some professionals. You'll see Apple, Hulu, the US Navy, Nike, YouTube, various post-secondary institutions and universities, and yes, Hershey's, the chocolate company. And how do we do this? We do this typically and mainly through our XR development with Unity course. It's all live and online in real time with our instructors, who are all developers as well. It's 10 weeks, 4 hours a week to commit to. And if you're interested in ever diving into this, September 28th is when our new and next course starts. And what differentiates us from all the other educational providers out there? It's the one-on-one support that we offer. Our courses are project-based, meaning you come in with an idea and a project that you want to develop, and we support that development alongside you over the 10-week period. Now, the second thing that we do here at Circuit Stream alongside training and education is content creation. In other words, we build VR and AR applications for organizations around the world. And these are some of our clients that we're extremely happy to work with and help implement, manage, and create VR and AR experiences. If you have any HoloLens 2 projects or applications you'd like some support on, or just to talk more about, we're more than happy to guide you there, to support that development, and to create something together. And alongside the training and education, as well as the content creation that we do, the third thing that we focus on here at Circuit Stream is our XR platform. It's a platform to host AR and VR applications, scale, distribute, and manage applications, as well as to track, measure, and analyze learning activities. So I will toss in a quick, short 2-minute video here highlighting the Circuit Stream platform, and then we'll continue on.
Welcome to CircuitStream. Since 2015, we've taught over 25,000 people how to build innovative XR applications. Now, we're bringing everything that we've learned together into the CircuitStream platform, a central portal for everyone in your organization to experience, distribute, and even create XR content. Log into the platform and you'll be able to launch and experience your organization's XR applications with the click of a button. Our CircuitStream Hub removes all the friction of installing and updating apps by handling everything automatically in the background so your employees don't have to. While users are in XR, we capture data from the application, allowing managers to track usage, structure pilot projects, and express ROI to stakeholders. Working together with CircuitStream, we can build analytic views around your key performance indicators and the unique problem sets that you are tackling with XR. Managers can set up and control access across the organization as you expand and scale your XR applications to train employees, communicate ideas, or do something amazing that no one has even thought of before. Our goal is to give you the tools for innovation. If you have XR developers within your organization already, they can also use the platform to upload their own applications and manage them efficiently by publishing updates and tracking quality assurance issues. The CircuitStream platform is built to manage and scale across the organization, whether you are creating your applications internally or working with an outside vendor. Start experiencing, building, and scaling XR today with the CircuitStream platform.
Wonderful. So that's a little taste of our CircuitStream platform. But now that you've learned a little bit about us, why are you all here today? What are you going to learn? Today, we'll be giving you a better understanding of the HoloLens 2 capabilities. We'll also go into device-specific knowledge, the UX UI understanding of the headset, and the fundamentals and frameworks for MRTK development. Now, before I dive into, how someone actually creates their HoloLens 2 project and introducing you a little bit more to the HoloLens, I want to show you what some companies are doing with the HoloLens 2 and how they're using it and how it adds value to them. So here is a quick, about 1.5, 2-minute video of how Airbus is currently using the HoloLens 2.
Airbus is a company designing, manufacturing and servicing commercial aircraft, helicopters, military aircraft, satellites and launch vehicles. Well, for the coming years, our challenges are huge. We have in the last 4 years delivered 10,000 aircraft, and we have to deliver twice that amount in the next 20 years. To face this challenge, we intend to make an intense use of mixed reality, and that's why we've started partnering with Microsoft. Mixed reality can help us to increase quality, safety and security. By having the right information in front of the eyes, the level of human error is significantly reduced. And in aerospace, an increased quality is an increased safety. I think the maturity of the services like Azure Remote Rendering of special anchors is key to give us the guarantee that we adequately use the HoloLens 2. It's key to have the right data flow. It's key to have the right rendering. It's key that the person using it finds himself or herself in the right environment with the right quality of data and therefore quality of visualization. So it's absolutely essential. The advantage of the HoloLens 2 in the design process is mostly in the validation phase, when the designer needs to know whether his or her design is really fit for industrialization. And this is hugely accelerated by 80%. On the manufacturing side, we use HoloLens 2 to enable the workers to achieve complex tasks or tasks that require an intense reading of documentation, while finally they're hands-free and they can access complex areas, they can handle heavy parts while having all the information they need right in front of their eyes. So we strongly believe that mixed reality can bring improvements up to 30% of some of our industrial tasks.
Wonderful. So Airbus really working with this technology, especially the HoloLens 2, obviously adding some value there. So fabulous to see. And for the French there, j'adore cette vidéo, c'est trop fort. Now, how does actually one go about creating a HoloLens 2 application to use? I will toss in a quick poll here. And just out of curiosity, how much experience do you have with Unity? I'll publish the poll here. You can find it in the polls tab. But let me know on a scale of 0 to 10, how much do you know about Unity? How much experience do you have with Unity? I'm just looking at the results here, and it looks like, fairly even split, quite a few beginners, some advanced people. I see a 10 there. Maybe you can come and help lead some of our courses and programs. But for those of you who aren't too familiar with Unity, what is Unity? Unity is a free 3D development engine for building games, simulations, and experiences. It's the easiest way to begin making applications for XR. XR stands for extended reality, and it's an umbrella term for both VR and AR, and you could even say MR as well. Now, this is what the workflow looks like if you were to create your own application for the HoloLens 2. You have an idea and you bring that idea into a creation engine like Unity. From there, you create and develop your idea, which is then pushed out to the Microsoft SDK and then out to the relevant device like the HoloLens 2. Now, I will toss in another poll here just out of curiosity. Which devices do you own? And I want to see how many people might own a HoloLens. So I just tossed in the poll there as well to see what devices the audience currently owns. But I do see actually HoloLens 2. It looks like there's several people who own the HoloLens 2, and makes sense why you're attending the workshop today. But I see Oculus Quests as well, some mobile phones, but a nice even split between the HoloLens 2 and the Oculus Quest. Now, I know we kind of went through what Airbus is currently doing with the HoloLens 2, various applications that they're working on to improve efficiencies and productivity. But I will toss in another interesting use case that's related to employee onboarding. So I'm going to toss in another quick 1-minute video here just to give you a different perspective of how you can use the HoloLens 2.
First time I stepped into a cab, I was nervous.
I was lost. My first month, it was hard to remember every step, and it was hard to remember where everything goes. One of my best friend's moms literally tells me every single day how proud she is of me because down here this job is really, really good.
I have a 5-year-old, a 10-month-old. Coming home and saying that, Mommy's not going back to work the next day, that's my biggest fear.
Everyone at Packard wants to be successful, but a new employee, it could take you multiple cycles to get up to speed. Every company struggles with training. Products are much more complex, so how do you keep up? We see guides and HoloLens as a great tool to change how adults learn. There's video built in, there's step-by-step instructions, they can overlay holographic images, and so when you have in-depth training from an electronic mentor, we believe you'll be up to speed in a compressed time frame.
It trains you, because I never done that and I know how to do it now off the first try. I think it's a really good, useful tool.
It was exciting, I don't know. It's super cool. It showed the entire harness going through the door. If I took those glasses off, I can't see that running all the way through there. By wearing the glasses, people would feel less pressure on them.
From what I've seen from the new hardware, I think it's going to knock it out of the park. Increased field of view is fantastic. Wearability is the other one. You get a much more immersive experience, one that people can use for a longer duration. I don't think there's anything close to this.
Beauty. Well, you've learned a little bit about us, a little bit about, the workflow of how to create your own idea or HoloLens 2 app in Unity. Now I'll quickly introduce you to the HoloLens 2 for those who aren't too familiar with it, and then we will invite Eric and Nakisa onto the stage here. So what is the HoloLens 2? The HoloLens 2 is the second iteration of Microsoft's revolutionary head-mounted mixed reality or augmented reality device. It has improved spatial and contextual understanding enabling a new way of interaction compared to various other AR devices on the market. It's a self-contained device with an onboard computer and built-in Wi-Fi, which acts as a client for data on the device itself. So compared to the HoloLens 1, it's an almost completely new product with more computing power, better sensors, longer battery life, and a few extra properties that we should point out. It's got a bigger field of view, as he mentioned in the video I had just shared, which enables the user to see more information and makes the device more interesting to use with applications that present a lot of information. There are completely new, more intuitive hand gestures, which enable easier content manipulation. And Eric will be touching on the hand gestures piece here shortly. Any command could be a combination of the user's hand movement combined with voice control. So, it really, I'll show you another quick video here, but today is an intro to HoloLens 2 design and development. So I'm just going to share another enterprise use case and application, specifically Philips in the healthcare industry, just how they're approaching things with the HoloLens 2, and then we'll get going into the theoretical and technical piece here shortly.
In the image-guided therapy business of Philips, one patient every single second somewhere on Earth is treated with one of our products. So that's 28 million patients a year could be treated because of the work that we do here. That was the big reason I came to Philips. Image-guided therapy is modern-day surgery without the incision. We're navigating tiny instruments through the body through incisions no larger than a pencil point. We're relying solely on X-ray images or medical imagery to guide us. So that means we are always looking at a screen of data.
With HoloLens, we can take it to the next level. We are a leader in image-guided therapy. And with Azurion, we created an industry-leading platform that customers really love. What's really cool about it is we've leveraged novel touchscreen technology to create a very powerful working spot for the physician.
Wonderful. Lots of use cases with the HoloLens 2. I could share so many more videos, but we only have so much time. So again, today is an intro to HoloLens 2 design and development. So I will invite my colleague Eric onto the stage here. And as he's coming onto the stage, I will quickly send you or share a 1-minute video of what the HoloLens 2 can do, just to hype you all up as Eric makes his way onto the stage here. And what better way to transition to Eric? That hummingbird, that was all Eric there. So Eric, pleasure to have you. Thanks so much for joining us. You're all in good hands. And after Nikisa's bit wraps up, which will be right after Eric, we'll wrap everything up and have our Q&A session at the end. Take it away, Eric. Thank you.
Thanks, Steph. The hummingbird was not all me. It was the team working together. I had a hand in the pot, but plenty of people helped with that. Really great hummingbird. So I was actually a UX design engineer at Microsoft while we were developing HoloLens 2. And for me, it was an incredible, awesome, eye-opening opportunity. I was actually embedded on the design team, and my job as a UX design engineer was to kind of struggle through the reality of this unfinished device, this thing that was just as much idea as it was product, and help the designers bring their vision for what this product would be into reality. And so I did a lot of work, just trying to get it working, just trying to make this kind of thing happen. And so I had to learn a lot of lessons about what HoloLens is and what it's capable of, and what are the strengths of it and how to get around the weaknesses of it. And so today I'm here to talk to you because I want to help kind of pass on some of that knowledge and some of those learnings that I've had about what a HoloLens is for, what makes it great, how to build for HoloLens, and to produce apps that have really great designs, really strong technical backgrounds, so the products that you put out on a HoloLens help that device shine in an amazing way. So I will turn on my screen sharing here and get you guys seeing my slides. And so, like I said, very much my talk is just kind of the intro to how do we think about developing for HoloLens? Like what is it that makes this product stand out? When I was working at Microsoft, we would get these prototype devices that were literally half of a device. Like there were parts that were not finished and not missing, and it really had us to focus on specific aspects of, like, today this is working, so this is what we design around. Next month, maybe something else is working. It's sort of you're building the plane as you're flying it, so to speak. But now that we have a released commercial device, you can look at the whole gamut of what this thing is and try to understand it as a gestalt. And so a lesson that I learned in this process of building these half HoloLenses and working on applications where some of the sensors worked and some of them didn't, is that the HoloLens 2 is really a different beast. When you're designing for familiar platforms like PC and Mac, they have their differences, they have their idiosyncrasies, but they're pretty familiar, they're pretty easy to understand, and a lot of platforms are very similar. Difference between PC and Mac is really pretty minor. But you could get to kind of cutting edge, newer technologies, and maybe they reimagine some elements or bring about some new designs. You have to think differently about them. And if you get to some really strange kind of edge devices like iWatch or voice things, like they're really kind of a different animal. And you have to come up with new ways to think about those designs, and what makes something like an Alexa good is a lot different than what makes a smartphone good. Well, then HoloLens 2 came along, and it really is just this absolutely totally different thing that takes some common elements from different platforms that we've designed before, and you can see those pieces in there. But in a lot of ways, HoloLens is just such a revolutionary, far out device that I think in a lot of ways we don't even really understand some of the things that this design is kind of necessitating. Like head-mounted AR is really kind of a new field that we're still inventing and understanding, and to dig into those idiosyncrasies is really what developing on a HoloLens or a Magic Leap is right now. So those differences in kind of how we think about design are really important, both because you need to respect those differences. They'll make your job a lot harder, and if you don't respect them, you can get lost in that. But also because we need to leverage those differences. The reason HoloLens is great is because it's not a smartphone. It's those ways that it differentiates itself from what we had before. And so in a way, like the real gold, the stuff you want to dig for in your own applications are the ways that HoloLens differentiates itself from other devices. And that's where you get your big payoffs. So in a really practical sense, in order to make a good app on HoloLens, like you're going to need to be working on that device. There is no substitute. You can't develop an app on your PC or on your Mac or on your smartphone, even using some IR pass-through on your or AR pass-through on your smartphone. It's just not going to be the same. So you really have to get that device early, test often. Like if you're on that device once a day, just so you can see your designs they'll actually be seen. There were so many times when I was working at Microsoft where we would finish a design on a device that hasn't been invented yet, essentially, and then put the design on the device and just be like, nope, square one, start over, it doesn't work. And that's just part of the learning process. And now we have a luxury of, instead of 6 months down the road, once you've finalized your work, seeing it on the device, you can see it on the device from the very beginning. So test on device regularly, but also, and here's sort of the flip side, if you've ever worked on an embedded device before, it's a lot of pain. And like any kind of cutting edge new technology, HoloLens it can be rough times. There, why doesn't this compile? Why doesn't it deploy? Like, why isn't my sensor being found? You want to be able to also iterate quickly off the device. So spend a lot of time tuning and tweaking in Unity in an editor where you can iterate very quickly, and you don't have to constantly be deploying to that device. So test on device regularly, but iterate off device as much as you can so that you can stay very quick. Another thing that I think is more philosophically really important to understand about HoloLens is the HoloLens is all about its sensors. It is just an amazing piece of technology as far as awareness of the world, right? And that's such a key piece of augmented reality, right? Because augmented reality is about understanding the real world and then overlaying computing on top of that. And the HoloLens 2 is really best of class. There is nothing better for understanding the world from a computing perspective than a HoloLens 2. So it's really important to think a lot about the sensors that the HoloLens offers you, and then build your applications around those sensors and the capabilities of those sensors. So no other device, no other AR device has the same kind of millimeter precision as far as knowing where the HoloLens is, where you're looking, where things like the surfaces around you are. A tabletop, you can know within a few millimeters where a tabletop is, and then you can put a hologram on that tabletop. And so by thinking about that kind of sensor, you can learn about what kind of app you want to build, right? So you have your understanding of where the HoloLens is in space, its orientation, where the room is, where you have collision on your walls and your tables. You also can do things like using Vuforia images or QR codes to provide very accurate, specific tracking for like a printed image, essentially. So you can, like, say, print out a Vuforia image, and then you now have a piece of paper that functions like a tracked virtual reality controller for your HoloLens, that you can do all sorts of tangible, feelable, physical things that, on an iPhone or an Android, the tracking is not so great. Even with a depth camera, it can't understand the world in the same way. You're not going to have that same fully integrated experience that the sensor suite on HoloLens provides you. And finally, the really amazing piece of sensors that are on HoloLens are the hand tracking. HoloLens, hands down, has best of class, fully articulated hand tracking. You know where every joint is to just an incredible degree of accuracy. And focusing on that hand tracking sensor suite and its capabilities is a really key part of making a good HoloLens 2 app. This is also a way that this technology differentiates itself from all other technologies, right? Because even with a smartphone that has a pretty good image recognition hand system, has a depth camera, you're still fundamentally holding your phone with one hand and gesturing with the other, and that's not nearly as good of an experience as two hands free. Like, I'm moving around my hands, both seen all the time by a head mounted display. So as you design your apps, make sure to put hand interactions first. It's the most intuitive way that humans interact with the world, and it's going to be the most intuitive way that humans ever interact with computing. It's sort of a dream come true that we can just reach out and touch virtual constructs when we're using a HoloLens. That said, it's also really important to understand that as these sensor suites enable humans to integrate their intentions, their desires, and their bodies into the computational world, it also means that it leaves a lot of people with an inability to integrate, whether that is an accessibility issue. If somebody doesn't have a hand, or they have a different number of fingers, or maybe they have a stigmata that makes the eye tracking not work on a HoloLens because their eyes don't converge the way most people's eyes do. There are more and more, like as technology gets more advanced and more capable of understanding ourselves and our body and our world, there are more and more exceptions to its ability to understand that, right? If the only way I interact with a computer is a mouse, then I can move a mouse with any part of my body. I can substitute a mouse for an eye tracker or a joystick or any other kind of pointing device like a touchscreen. And there's all these different ways that people can adapt themselves to computing. But with the increased sensor fidelity on a HoloLens, it's harder and harder for people to adapt themselves to computing, and computing needs to be more willing to adapt itself to people. So that might mean, I have something in my hand, so I can't use hand tracking right now. It might mean that I'm wearing gloves, and so the hand tracker can't pick up my gloves because they're like IR transparent or IR opaque. So it's really important to use all the other sensors in addition to that. That's why you want to use voice, you want to use eye tracking, you want to use hands, you want to be able to cast rays and use air taps to interact with buttons. This example's a tooltip that shows you how to use voice commands to activate a button that would normally be pressed with, say, your index finger. So again, it comes back to you have all of these robust sensors. It's really important not to rely on a single one of them. Try to make your app as accessible and as diversely controlled as possible. And as one final note to that, as more and more AR devices become portable like HoloLens, I think we're going to see more and more of these exceptions, right? People move away from a setting where they're sitting at a desk fully committed to operating a PC, and suddenly they're out in the world, they have a kid in their hands, they're driving their car. There's all these different things that start interrupting computing, and it's really important to think about how your app can be controlled through lots of different sensors. So users have tons of bandwidth to express themselves to HoloLens, right? And it's up to you as a designer and a developer to utilize all of that expression, to capture that intention of the user. In the same way that they have a huge amount of bandwidth, you need to express back, you need your app to express back to the user with a ton of bandwidth. Every single one of those interaction methods that comes from a different sensor, right, needs to express some feedback back to the user. So if your app uses eye tracking, right, you eyeball over some object, your app needs to provide feedback to a user when they're interacting with their eyes. And that feedback needs to be different than the feedback that might come when you move your hand near a button, or when you use a hand ray near a button, or when you activate something with a voice. It's really important to just, kind of go into feedback overload. You need animations, you need sound, you need coloring changes, you need selection states, and you need to constantly be communicating with the user about what all of your sensors are picking up. Everything that the device understands about the world, you need to confirm to the user that you understand that and that they can utilize that information, right? And it's also double important now when AR is new and people don't just assume that everything can be controlled by voice, right? Is they need some kind of feedback that reminds them of all the new capabilities that come on this device that maybe 10, 15 years from now, when AR is old hat and nobody has anything new to learn about it, those affordances won't be so important. People will just assume that they work. But as for the short term, you need to be constantly teaching these new capabilities to people. And so finally, one other thing that is sort of beyond the sensors of the device that empower the sensors of the device is HoloLens 2 is a relatively low-powered computer, right? It's a mobile processor, doesn't have a ton of RAM. It can't do a lot on board, and ultimately everything you do on board drains the battery. So you want to constantly be thinking about ways that you can use the sensors on the HoloLens to power computing that's happening in other places, right? Cloud services like cloud rendering can render just amazingly complex, highly detailed graphics and then stream them in real time to your device. And then you can see, a semi-truck just exploded and cross-sectioned in incredible detail down to every single screw, and learn things about that you'd never be able to learn on a real physical semi-truck that has weight and mass and can't be taken apart in an instant. There are map services that you can integrate for like real-time location data, and maybe you want to see the buildings across the street through your wall. Like, you can do that by leveraging those cloud services. There's real-time translation, data service visualization. Microsoft is really pushing Azure services to support HoloLens, and so if you're working on HoloLens, like, take advantage of that. Like, they're dumping a ton of money into making your app better via some cloud service. So look into that. Look into ways that you can offload some of that compute, some of those more challenging tasks from the device itself, and focus on gathering data via those amazing sensors that are on the HoloLens, and then displaying it in that most amazing heads-up way that only a head-mounted device can show you. To kind of wrap it up, remember, HoloLens, really important, unique new device, specifically powered by tons of amazing sensors that will guide you to the things that will make the best app. Focus on hands, but make sure to cover every other sensor, every other kind of input. Invent new ways for users to provide input by thinking about what kind of data those sensors provide. Is there something you can do with eye tracking? Is there something you could do with hands? Is there something you can do with sound? There's a really great microphone on a HoloLens. And also communicate back, constantly be expressing what those sensors are understanding back to a user. And that's going to take a lot of your budget. You're going to spend a lot of time working on good feedback, and that's worth it, because that's what makes your app stand out from all of the other HoloLens apps and all of the other uses that other devices. There's so many ways to compete with the HoloLens. Anybody can read a manual on a tablet, but it makes a difference if that manual is a hologram hovering in the world pointing to a real object. That's how you differentiate yourself. So think about those sensors, find ways to move those computationally challenging things away onto the cloud, and focus on getting great sensors, great feedback through that awesome display. And then you're gonna make a super incredibly cool application. So that's about all I have now. I'm going to pass it off to Nikisa. She's going to dig into some technical specifications, some real details, and some juicy bits about how to actually create a HoloLens app. There's a really great toolkit that actually helped author called the Mixed Reality Toolkit, and it's a way to go from pretty vanilla Unity straight to taking advantage of all of these capabilities of HoloLens. So Nikisa is going to come teach you how to do that. There's all sorts of great, setup tricks and ways to get into it fast. With any new technology, there's a lot of pitfalls to go into, but she'll get you over those pitfalls, and we're going to make a cool little hand-controlled app in the next 45 minutes or so. And then I will return after that, and Nikisa and I will both do some Q&A for anything you want to ask either us about design or development. Thanks, guys. Good luck, Nikisa.
Thank you. Can everyone hear me? I know you can see me, but can you hear me? Yar. Cool. Loud and clear. Awesome. So I'm going to take you guys going from scratch to actually deploying to a HoloLens device that I have sitting on my desk right here. And that whining that you hear is my dog that really likes attention. And apparently I'm okay with that. Hi, Juanita. Nice to see you again. Yes, this is recorded. So let's dive right in. There are a number of tools that you need to download once you get started. And since I love using my paint, I'm going to show you guys what that is right here. Well, not rule, but numero uno of what you need to download. Windows 10. You need Windows 10 on your PC machine. So now that you got that downloaded, the next thing that you need is Visual Studio 2019 and version 16.2 or higher. Up there. And then the third thing that you need, and a very, very important third thing, is a very specific Windows SDK. You need Windows 10 SDK versions 10.0, 183, 16.0. There's the magic number. This is very, very important. If you don't have this installed on your computer, you're going to have some pretty strange computational errors once you try to build that. So the fourth thing that you need is either an actual HoloLens device or an emulator. But you need those 4 things to start making stuff on your HoloLens. Capiche? You got it? Making sense so far? Yeah, you guys got it. Nice. Good. So, the other thing, before we dive into Unity itself, I want you guys, if you guys are following along, and you probably will, once this recording is up there, you guys are going to go to releases, this GitHub release right here. GitHub.com, Microsoft Mixed Reality Toolkit for Unity. Now, MRTK, as Eric has described, is the thing that does all the magic that you can just drag and drop, add component, add little blocks of code, and you can get yourself up and running for a lot of different devices, including the Quest and the HoloLens 2 and the HoloLens first generation. So then, what you need to do here before Unity, before we dive in there, I'm just getting you guys all set up, setting you guys up for success. This package right here is the thing that you want to download. Yes, it is version 2.4.0. This is what you're going to download and import into your Unity project. So let's make a Unity project. Today, we're going to be making a little bouncing ball, a little digital bouncing ball that'll have some spatial mapping and it'll bounce all over your area, I guess. Super cool. Spatially aware digital objects. If that's not the coolest thing right now, I don't know what is. So let's dive right in. Open up your Unity Hub, and we're going to create a new version of Unity. Now, it is recommended when you're developing for a HoloLens 2 to use a version of LTS, which is long-term support. Right here. So we have 2019.4.1, and that's the version that I'm going to be using. So I'm going to create a new project, clicking this and clicking that. And let's say this will be my let's shout it, caps lock. HoloLens 2 bouncing ball, because that is what we're going to be doing. Let's specify the location. And let's go to Unity. Now you guys will be getting a link to the GitHub repo for this project that we are creating, and it will be this one in this. And you see this little .git file, that means it's going to be a GitHub repo. So this is the folder I'm going to select and build my Unity project. Now this is a 3D template right here. So let's click on that lovely button, create. And it's opening. And as this is happening, I will ask you guys a question. Why did the wolf start meditating? Because he wanted to be a werewolf. Because he was bored. Right? Oh, come on, Brian Moses. Alrighty. Oh, this is an interesting little interface. Now, this is a custom interface, so let's return this to the default, which you will see. Go to Windows and Layouts and go to Default. There we go. So, all lovely, lovely. This is the Unity interface that you will be working with, and let's actually see the polls. Who has experience with Unity on a scale of, okay, cool. So on the, I'll just give you a brief overview. Left-hand side, we have the hierarchy. This lists everything that will exist in your HoloLens application. Once you turn it on, start the app, all of these little things are called game objects, and that's what you want. And so when I click on one of these things in the inspector tab over to the right over here, this will list all the things that make up this game object. Kind of like poking into a body. Let's not go there. Anyways, I retract that comparison. It's a list of all the things that make up the game object. So remember that package I told you to download from the MRTK releases? This is where we are going to import that custom package. At the top left, we're going into Assets and Import Package and Import Custom Package. And now we are going to search for where I downloaded that lovely Unity package. And it is in my Passport and Downloads. And which one is it? We want the foundations. The examples is also a good package that you can import into your project, although it's not necessary. We want the foundations 2.4.0. And import. You know, it was really foggy a couple of days ago, and I got really angry because I just wanted to punch it. I wanted to punch the fog, but I missed. Hey, Jared. No, it's not okay. Actually, it's okay because I can't hear you. So this is where we are going to import all of that. Oh, we are so going to get serious. Totally serious. No regrets. We want to import all, so click on that button and go to Import. So as this is importing, this will be a little tidbit into, you know, creating your little AR sports. And like AR ping pong. That'd be cool. But you totally could. And maybe you'll see my juggling skills. I have no juggling skills, but I will try. Oh, that would be pretty humorous, you know? Pretty humorous. But here's a good question for you guys too, though. Where do you go for a peekaboo injury? You go to the ICU. Mark Casey. You beat me to it. You know, at some point during my life, I broke one of my fingers, but on the other hand, I was okay. Okay, so now that we have imported MRTK in our project here, we are going to see this little window pop up. Now this is going to apply some Unity settings that you want in your project. So we want to enable that legacy XR services, that thing, and then we also want single pass, and then we want to set the default spatial awareness layer, which is just layer 31, spatial awareness. So we want to click apply, and that'll apply all of the settings in your Unity project. And wait for that to load. And that is done. Well, thank you. So that is done, so we can close that right now. And then the next thing that we want to do is we want to make sure that our build settings are correct. Now, this is very, 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 very important. So let's go to the edit and project settings first and foremost. We want, oh, I lied, sorry, it's the build settings. Edit, or sorry, file and build settings. And that is on my other screen here. Where did that go? There it is. Our build settings. So since we are building for the HoloLens, we are going to switch to the Universal Windows platform, and we also need a scene to build. So we can just click on the Add Open Scene. It's going to build the sample scene inside here. Now, the architecture of the HoloLens is slightly different from your first generation of HoloLens. You're going to switch this target device to HoloLens, and the architecture here, and this is very, very important, it's not ARM, which is suggested in the 2019.3 versions of Unity, but since we are using a 4 version, 2019.4 LTS, we are going to use ARM 64. And now, since I have my HoloLens plugged into my USB port, this is going to be on my USB device. And then, remember that Unity or that Windows SDK version? What was that number again? It was 10.0 point, what now? 10.0.8 point something, 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 something. There it is, this one, 18362. This is going to be the minimum platform version. So you can click on that, and there it is, 18362. Clicking on that. Now, this is a very important step, or else you will not be able to launch to your device. You'll get some weird stuff going on there. And then once this is done, we are going to click on Switch Platform. I'm waiting for you guys to suggest any puns. I want to hear some from you guys. It happens, it happens. Okay, so now that we've switched all of these things. That's awesome. That's staying up here. What kind of exercise do lazy people do? I have no idea. Diddly squat. That is awesome. So click on apply once this thing pops up. Apply. And we are good to go. We need to get our scene all set up to do the HoloLens things. So way up at the top, we're going to click on this Mixed Reality Toolkit and the utilities right here. Actually, not utilities. Utilities and Configure Unity Project. This is what you're going to click on if you did not do that. Click on Apply Settings. So what we're going to do, are you a game object? Because you look real to me. What do you call an old snowman? A puddle. So we're going to configure the scene in our project. So we don't have to do anything right now. We need 2 different game objects that this thing is going to configure, this lovely little button. Click Add Scene and Configure. So right away what we see is we see 2 different game objects being created. One is the Mixed Reality Toolkit, and the other is the Mixed Reality Play Space. Light travels faster than sound. That's why some people appear bright when you hear them speak. Oh my God, Kyle. Why is 288 the lowest number? Man, these are brilliant. This is so good. I don't know. Why did he stare at the orange juice? I love it. Okay, concentrate. We got to stare at the orange juice now. The orange juice is the Unity project. So right away, we see the mixed reality toolkit here, and this has a bunch of configuration files on it. So what we need to configure is this mixed reality toolkit right here on the right-hand side for the inspector. We can't modify these profiles directly, although you can if you're a little bit of a wizard, but it's recommended to just clone them and do your own things to them. What is the difference between mixed reality toolkit and the place-based objects? So your toolkit is basically a whole list of configuration files. So things like your input, how are you going to visualize your hands, your hand tracking, as Eric has said. And then you also have your spatial awareness that you can configure. And you can also configure voice and stuff like that. Okay, you need both. You need both your toolkit and your play space. And remember your play space, or you can remember the button to configure these things is right at the mixed reality toolkit and add to scene and configure. And under this, you have your main camera here. Your main camera acts like what you see in your HoloLens. Must have been real painful. So right away, we're going to configure some of our stuff, some of our mixed reality toolkit stuff. We're going to click on clone, and we're going to rename this to HoloLens 2, and this will be the config profile. And then that's going to be in the custom profiles folder, so click on clone. And there it is. The next thing that we are going to clone next is the spatial awareness, because we want our digital ball to be bouncing around our area. So it needs to be spatially aware. So on the spatial awareness, I'm going to click on clone here. And you know what? I'm going to rename this to HoloLens 2 Spatial Awareness. And click on clone. Now, since we have created a spatial awareness system, we need something to observe that system. There is no Schrodinger's cat here. We are absolutely observing that stuff. So you can click on Add Spatial Observer. Well, actually, it's already created one for us, so I can just remove that one. But this Windows Mixed Reality Spatial Mesh Observer, this is another profile that we are going to configure and clone. So I'm going to click on clone here and rename this to, let's just rename this to HoloLens 2 Spatial Awareness Mesh Observer Profile. That is a mouthful, but it's descriptive. So click on clone. And then the next thing that we can do is we can change the visibility of the spatial mesh. So what the spatial mesh is going to do is going to overlay a series of triangles over your room. And so it can be aware of, your environment and be aware like the werewolf. So that is all done. That is all done and configured, which is super cool. Now we're going to do the thing. We're going to create some balls, some lovely bouncing balls. I'm going to create a game object here that will be all-encompassing for digital objects. It'll be my scene content. So I'm going to right-click in the hierarchy, go to create an empty, and let's rename this to my scene content. And you know what? Let's anchor this scene content into the world. Let's anchor it to a certain position. So I am going to click on add component, and I am going to add a world anchor. And so right away, when this thing starts up, I want my scene content to be positioned at a certain place. And I already know what feels comfortable for me, so I'm just going to set that in the X, Y, and Z positions of this thing. Let's do 0 times 0.7, and for the X, and the Y, it'll be 0.171. And in the Z, let's do something like 0.98. I'm a very particular person. So the next thing on this scene content is I'm going to have like a little table, and this table will already have this ball on it. But whenever I like click on that table using my hands, and that's another thing, we'll configure the hands later when we get there. Or if you know what a malaprop is, mal4, we'll burn that bridge when we get to it. But we're going to have this little table there, and when you click it, it'll instantiate another little bouncing ball in case we lose it, and we're just sort of chasing this digital object, which may look a little strange to outside observers, but you know what? They're not a spatial observer. They don't have to know. So I'm going to right-click on this scene content and go to 3D object and a plane. Now this plane is pretty big. So let's make sure that this is something pretty small. Maybe this is like a, let's see here. I'm gonna click on my R, scale that down, and let's do something like that. There we go. There it is. And let's position this to something like, and I already know these values. You don't have to worry about it. Negative 0.5, and the Y, and then Z will be like negative 0. Like so. So this plane is going to have my little bouncing ball on that. So let's create a prefab for my little bouncing ball. In my assets folder, I'm going to create a number of different folders to house some of the things that we are going to create. I'm going to right click in my assets, go to create folder, and this will be prefabs because that little bouncing ball will be a prefab. And I'm going to also create another folder that is material, because let's use some of that MRTK material stuff that is optimized for the HoloLens and AR experiences. And let's also do another folder for scripts. And you know what? Let's do, actually, no, that'll be it. We'll see. But let's create a bouncing ball. I'm going to right click in the hierarchy, go to 3D object and a sphere. Now this sphere is a size of 1, 1, and 1. Now this is in Unity units. And in Unity units, 1 is equivalent to 1 meter, which is pretty big. Sorry for all you Americans, you should just adopt the metric system. 1 meter is like, let me show you what 1 meter looks like. It's like this big. Yes. So this is a pretty big bouncy ball. It'll be like a little beach ball. Let's scale that down a little bit. Let's hit R on my keyboard and scale that down to something like, yes, puppy, hello. And there it is. It's slightly longer than a yard. I hope your yard has milkshakes. So since we want to grab this thing, and you know it looks kind of boring, let's create a material for this thing. We're going to create 2 different kinds of materials. We are going to create a material for color, and then we're going to create a physics material, which will have the bounciness to it. So I'm going to right-click and create a material, and let's say this is my ball. No, I keep saying it. And he's like, play, material. And let's change this standard shader to MRTK, and let's do a standard shader. And let's change this albedo to red. A nice red ball. It's 2 a.m. Wow, trooper, that is dedication. That is really dedication. So I'm going to apply this material to that thing right there. Let's see. Yes, okay, that sphere is there. Let's actually return this to the position of 0, 0, 0. And we're going to make this into a prefab. But before we do that, we need to add another component on this sphere. And let's also rename it to my bouncing ball. Now, the thing that actually does the collisions or the forces itself is something called a rigid body. You can, I know, right? AR basketball? Absolutely. So there is a component in Unity, for those of you who are not Unity experienced. It's a component called a rigid body. Now, a rigid body is something that applies what I like to call Newtonian forces. Newtonian because who is Newton? What is he famous for? Has to do with an apple. I'll wait for you guys to shout it in the chat. The gravy is the gravity. That is true. Gravity. So I'm going to add a rigid body component to this bouncing ball because we want it to fall. We want it to bounce. We want it to experience forces. May the force be equal to... I'm pausing because I'm letting you guys answer in the chat. MA. Exactly. Not MMA. That's a different kind of force. But MA. I'm going to add a component and add a rigid body. Now, this rigid body will be using gravity. And this plane, you know what? Let's also have this plane be a rigid body, but a different kind of rigid body. I'm going to add a rigid body here. And this rigid body is not going to be using gravity. Otherwise, it would just fall. We want this to be kinematic. What is a prefab? A prefab is a prefabricated game object that you can reuse over and over and over again. And it will exist inside of your project as opposed to just existing in the scene. Because we are going to do some instantiation. Don't even know if that's a word, but it is now. Now, the next thing that we want for us to actually, for us to actually interact with this bouncing ball, there are two things from the Mixed Reality Toolkit that we need to add to this thing. One is called a near interaction grabbable. This thing will allow, this little script here will allow you to grab it with your hands. So you can just like reach in and pluck it. Then the next thing that we need is something called an object manipulator. So manipulative. I'm just kidding. This thing will allow you to do some one-hand or two-hand manipulations for your ball. Now you can also select it from a distance, or you can reach in and grab it on there. So your manipulation gesture is like using your two hands and sort of going like brip, 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 and sort of turning all those things. That's what you saw in the videos about people expanding game objects, or compressing things, or waving things away, doing a little queen wave. Begone, plebeian. I'm just kidding. So we have the object manipulator there, and so let's set this object to rotate about the object center rather than the grab point, and do it that right there. Let's see. And that'll be it for the bouncing ball. Now that we've created a bouncing ball, we will be able to grab it. And we'll make this into a prefab by dragging and dropping this into my prefabs folder right there. So see right away it turned blue. That means it's a prefab. That means if I delete this from the hierarchy, it is still there in my project. And now we have a little bouncing ball. But you know what? Let's have it in the scene already. I'm going to drag this bouncing ball right there. There. Cool. And you know what? let's click on this table, and when we click on this table, let's have it play a sound maybe, and then let's also instantiate another bouncing ball, and that will be a script that we will write. Now, this will be a trick question. What is the thing that allows me to grab and touch and manipulate an object? What's that component? We just used it, but I'll tell you anyways. Yes, you need fingers. You do need a collider, and there's a collider here. And the thing that we need here is the object manipulator. That's the thing that we're going to use to instantiate the game object to recognize the manipulation event there. We can write our own script by using an interface, but this is much better. This is much, much better to use. So we have a plane, we have a bouncing ball, and you know what? On this plane, let's also add an audio source so we know when we have clicked it. Like so. And this audio source, the 3D settings, let's set this to be, where is that? Spatial blend of 3D. That way we'll be able to hear it from walking around anywhere. Alrighty, let's do this, let's do that. The next thing that I forgot to configure is actually in our mixed reality toolkit here, because we're going to use hand tracking, and you know what? Let's visualize that hand tracking stuff. Right. Let's go to the input system of our MRTK. And we're going to clone this profile. And instead of the new mixed reality toolkit or mixed reality input system, we'll do a HoloLens 2 and create that clone by pushing that button. So now what we can do is we can expand this hand tracking, and we also need to clone this too. So let's click on clone, rename this to something a little bit more relevant. HoloLens 2, click on clone. Now, the next thing that we are going to do is this hand mesh visualizer nodes. We want this to be everything. So make sure that that is clicked. And this is the prefab that will be instantiated when we see our hands is this articulated hand mesh. It's that series of triangles over there that we'll see overlaid onto the triangles. So let's see, it looks like that is all set up. Let's get to the fun part. Let's script something that this little object manipulator will be doing. And so let's go to our scripts folder right here. I'm going to right click and create a script. And this will be, what are we gonna call this? Spawn ball thing. And I spelled it wrong. Rule number 1 of scripting when you are in Unity, or when you are using Unity. Rule numero uno, your script name, let's drag this here so you can see that script name. Your script name must be the same as your public class. So let's rename that. And let's decapitalize that. Double click to open it up. When it does, and it seems to be just like a wee bit frozen. That's right. That's right. We will make it bounce. Let's finish the script first, and then we'll make it bounce. You can also make it slip and slide. Make it a puddle, an old snowman. Oops. Right there. Let's randomize that. Alrighty, so we don't need any of this stuff. But real quickly, let's just have a public game object, and this will be the ball prefab. So, and then we'll have a public void spawn ball like so. Now we are going to instantiate this thing just like a little bit above the thing. So let's declare free position. This will be a little above the little plane that we have, that little table. And this will be a new vector 3, and so this will be, you know, same position as the x. Transform dot position dot x, and then it's just going to be up a little bit. So it'll be transform dot position dot y, and let's say plus 0.2f. And then it'll be transform dot position dot z. And that will be there. So next, we're going to instantiate the thing. We're going to say a game object, and this will be the spawn ball will equal instantiate. And what are we instantiating? The ball prefab, and where it'll be at position, and what rotation is will be transform dot rotation. Like so. So that is done. That is super cool. Let's get on to creating a physics material for this bouncing ball. This bouncing ball, I am going to right click, go to create, and we are going to create a physics material right there. And this will be bouncy. This bouncing, we're going to set the bounciness to something not 1 because we don't want it to bounce forever and ever and ever. This will be something like 0.8. And the bounce combined, we want this to be the maximum. Like so. And now we have to apply this material to the bouncing ball. Now to apply physics material, it'll be on the sphere collider. So I'm going to just drag and drop this onto there, right there, and click on the overrides and update this prefab. And there we go. Actually, well, let's see, double check. Let's see. We have that bouncy material. Okay, awesome. It is ready to go. So I'm going to save my scene. And on this plane, I'm going to apply my script. Spawn ball thing, right there. And that prefab, I'm going to drag and drop that into here. And so, to get this thing to do what I want when I tell it to on manipulation started, when I click on that thing, I'm going to hit that plus icon. I'm going to tell it to spawn ball thing, drag that up here. And that function is going to be that public function, spawn ball, right there. And then, you know what? Let's have it play a sound. This audio source, drag that right here. And we will play a audio source. And this will be play one shot. And you know what? Let's see. MRTK, you should have some sounds in here. Where are your sounds? And there it is. Manipulation start. Drag this into there. That little clip. Then we can save. And let's see. Let me double check what we have here, that same content, and this has a world anchor, so it'll be anchored in place, and this plane is right here. This plane has a rigid body that is not kinematic, and it has these things, and now this bouncing ball has the interactable item and the object manipulator. So then let's see what else we have here. Let's also make sure that the spatial awareness is on the same physics layer that we want, which is the 31 spatial awareness. This layer, this is the physics layer that digital objects will interact with. So now that that is all done, I'm going to save, and then the moment we have been waiting for, we are going to connect the HoloLens to the computer. So let's put this thing on. Sharp typing I have here. Well, thank you. Now this thing, it went to sleep, so let's turn this thing back on. I'm gonna do that. And as I'm doing that, we're going to use the device portal. First, let's do the pin. No, that was not the right one. And you'll see that I'm wearing glasses as I am wearing this headset. That's it. That's it. There we go. We are logged in. So, this is quite possibly the coolest thing. The coolest thing. So we have the HoloLens all plugged up. Now, what I'm going to do is I'm going to connect this thing to my device portal right here. Now, to connect it over Wi-Fi, because I've connected this to the same Wi-Fi as my computer, I'm going to go to 192.1, there it is, and hit enter. And this is my device portal. So we can see that it is online and cool. And you know what? You know what else is really cool? The mixed reality capture. But the first thing that before we actually start capturing it, is that we need to build the project itself. And we can hope that, the build settings are all set up. 16, okay. Build. We're going to create a new folder. Builds, like so. Double click in there, and this is where we are going to build things and select folder. And it'll build. There we go. There she goes. Well, you know what? There was, well, no, I've said this joke in my class, and I'm pretty sure you guys don't want to hear it. But I dreamt about Lord of the Rings last night in my sleep, and it turned out I was Tolkien in my sleep. If you guys are, you can, but as Eric has stated, when you are building for a device, you need to test, always on the device itself. You can iterate using tools, absolutely. Who are Star Wars fans in the crowd there? Have you guys ever tried Wookiee meat? I hear it's real chewy. Because I can't see you sharp. Okay, so this is a very important step when you are testing onto the HoloLens. You're going to right-click on this solution that Visual Studio built, right-click, and you're going to open with not 2017, but 2019, like so. And let's make sure that this thing is still, yep, okay, cool. And this will open my Visual Studio solution. Next. Very, very important next. I'm going to expand this right here. And we're going to make sure that when we launch from Visual Studio to the headset, that the architecture is going to be the same. We are not going to do an ARM architecture. It'll be ARM64. But the first thing we're going to change is this debug, switch that to release. And here, this will be ARM64. And this is not going to be the remote machine. This will be the device. And then, let's see. I'm going to hold my breath and pray to the demo gods that this actually works. You're going to go to debug and start without debugging. And this will launch. And at the same time, I'm going to go to live preview. And let's not do mic. Mute that. Okay, so that is what I'm seeing in my HoloLens, as you can see there. So let's see if this is all right. Holding my breath. Wait for it to do the thing. Just do the thing. I know, right? Right? How many psychologists does it take to change a light bulb? None. The light bulb has to want to change itself. You were just using this time to think about how AR basket game could work. Oh, that would be real cool. A man walks into a bar and says, ouch. That's a good guy. A snake walks into a bar and the bartender says, how'd you do that? Oh, let's see. This is usually the longest time. The longest time of iteration. Total compilation time, okay. All right. No, not yet. Not yet. It's still doing the thing. It is doing the thing. It's almost done. Can you hear me breathing? Because I'm not. Oh, we can see that the progress bar, it is almost done. Almost done. You know, I actually used to be scared of gardening, but then I grew a pair. That's right. I won't be able to feel it, but I will be able to see it. And this is deploying, copying files. Okay. Good, good. Faster. Oh, there we go. Build. Oh, here we. Okay, hold on. All right. So let's see. There is my hand. And that is the spatial mapping. Now then, where did it go? Let's go to all apps. There it is. HoloLens 2, bouncing ball. That is the. I am forgetting something. There is something else. There is a configuration that I had forgotten. Let's see. Hold on. There is there. Windows platform. Okay. So when you configure the scene in the utilities configure Unity project or the add to scene and configure, then Yeah, you know what? Let's see what this game is doing. Well, that is strange. That main camera. Okay, let's do there. Mixed reality input. Okay, that is good. That is fine. And let's see. Hold on. I think I know what it is. We are in the Windows. Let's go to XR settings. Oh, silly me. In XR settings, you have to add your Windows Mixed Reality SDK. The other thing that you need to do for your Windows Mixed Reality is to switch it to a 16-bit depth. Now, if you are using an emulator, you might need to check WSA holographic remoting supported. Oh, why aren't Pyres into virtual reality? Someone said that earlier. Who was that? Can you pre-configure all of these settings, or do you need to go through it every time you start a new project? You do need to go through it every time you start a new project. And let's see. Make sure that is there. Switch this to 16-bit. And let's see. Close that. Now this game view is a little bit different. And then let's go back to project settings here. VR supported. Yep, that is okay. Let's go to the other settings and make sure that this is all checked. We have there unchecked graphics job as well. We don't need that, and we do need the .NET 4. And then let's see what else that we have here. All right, that should be fine. And let's change this to solid color. And everything, perspective vertical, that should be fine. And you'll notice that the near clipping plane is 0.1. On the first generation, that is 0.3, which is 30 centimeters in front of you. All right. So then let's rebuild this thing. Make sure your scene is, oh, I forgot one of my own very first rules that I like to teach students. What have we learned from Nintendo? Everything not saved will be lost. So save your scene, Control or Command S, and then rebuild. And go to Builds and select Folder, and this will overwrite all of those things. No problem, Zach. Speaking of the Nintendos, how many Nintendo fans does it take to change a light bulb? But who knows, because they're all playing the Switch. The power of the demo and live stuff. You forget things that you wouldn't normally forget. Hence the praying to the gods, the demo gods. So now let's do the same thing. We're going to right click, and actually we can just close that as well. We'll ignore all, close that. Right click, go to open with 2019. Yes, test. Testing, test. So we're going to do the same thing. We're going to go to the release, and it is the ARM16, and it is the device. And then we're going to go to debug and start without debugging. Sometimes it's not the actual development that is the hardest part. It is actually getting it onto the device.
Awesome. So while we wait for this to debug, Makisa, I'll quickly wrap this up with 5 minutes. Then we can bring you back in to show everyone what it looks like, and we'll invite Eric back onto the stage here to answer some questions. We'll take about 15 minutes at the end here to answer questions. But I will just remove the stream here quickly, and then we can have you share your screen again. Now let me just enable my screen sharing. I know we're running into the 2-hour mark here. But again, Eric, thank you so much for showing us more about the design side of things. Nikisa, with getting this ball started. Looking forward to see what it looks like at the end here. But I know we flew through this content quite quickly. And, we would be more than happy to have you guys in our courses and programs should you have an interest in learning more about it. Whether it's a career transition that you would like to do, more than happy to help you out with that. We've had Syed take our course coming from the steel industry, and now he's actually starting his own XR business. If you have a project in mind for workplace, we had Laura Smith from SNC Lavalin take our course, and now she's applying it back to her work. We do offer private team trainings as well. So if you or your team have an interest in developing any VR/AR project, or for the HoloLens 2, we'd be more than happy to privately teach your group and team how to do that as well. Now, for those experienced people here on the workshop, we have our XR Project Accelerator course, and it's an advanced program really to polish up your projects and applications and make it into a professional environment. This course starts on October 20th, and the price of it is $44.50. It's 8 weeks long with 6 hours of instruction per week, 3 hours of one-on-one sessions, and 3 hours in class. So feel free to check out our website if you are an advanced programmer, designer looking to learn more about that. If you're a beginner, our XR Development with Unity course is a beginner-friendly program. It's all live and online with instructors like Nikisa and Eric, guiding you and helping you learn how all of this comes together. The next course starts on September 28th. The price is $39.50, and it's 10 weeks long, 4 hours a week, and that includes weekly private sessions to work on your own personal projects. We do offer payment plans and financing options as well, from 3-month payment plans to 6-month payment plans and 12-month payment plans for both the advanced course and the beginner-friendly program. For the beginner course, the XR Development with Unity course, you'll learn how to create and make your own VR and AR apps from scratch in Unity, the fundamentals of C# coding. It's 4 hours of class per week over 10 weeks. And again, all of our students get a private weekly one-on-one session to work on that personal project of yours. There is no experience required, so newbies have no fear. We welcome everyone from all walks of life interested in this. A Mac or Windows computer would do just fine for the course, though Windows computers and PCs are better tailored for this. And if you're developing for a mobile app, Android or iPhone works. Headsets are not required for the program, though it does add some value in that you can test what you've created and so on, as Nikisa's testing the ball there as well. So it does add value, but you won't be held back if you don't have a headset. Now, if you're interested in learning more about our courses or programs, or if you want to get into it, please check out circuitstream.com/course. We'd be more than happy to talk to you about it and to have you with us on September 28th or on October 20th. So with this, we can slowly invite Eric onto the stage. We'll see how Nikisa's ball demo. If it's debugged, it's good. All right, perfect. Let's check it out.
Alrighty. And I can unplug this and you'll still see it. There we go. And let's just open up that app. And there it is. Lovely, made with Unity. And there it is. So let's see. There is the hand mesh, so you can grab it like so. And then, let's just bounce it. Wicked. There's my dog. He cannot see this well. And there we have a bouncing ball that is spatially aware. I am not a very good juggler. There we go. Super cool.
That was great. That was great. But no, thanks again, Nikisa. That's I'll need to get my hands on the HoloLens too. I'll get one from the office or something, create my own experience. But thank you so much. That was wonderful. I see Eric has joined us as well. So we'll open up for our Q&A session. I know we have some questions in the question tab that we had forgot to, or maybe have missed to answer. So we'll chip away at those for the next 10, 15 minutes, and then we'll wrap things up.
We go straight to Q&A? Did I understand that right?
Straight
All right, great.
to
So
Q&A.
I've got a couple questions actually lined up, so I thought I would just jump in right with those. One of the first kind of sets of questions here is kind of talking about how accurately HoloLens can position a hologram in the environment. And this is sort of like, this is the bread and potatoes, the real meat of what it means to build an app. It's finding the right way to make your app smart about the world. So the most basic way to do that is using the spatial mesh, which Nikisa talked a little bit about. And basically, the spatial mesh is an easy way for the HoloLens to communicate with your application about where the physical world is, and it gives you a mesh that can both be visualized and collided against, that represents the world. And so you can anchor any hologram to this spatial mesh, and you have pretty good interaction for things like, a bouncing ball or some kind of signpost or something. But the mesh is a reconstruction of the world, right? And so you don't have the same degree of accuracy that you might want. There's it may look like a flat surface to a human, but maybe the detection feels some bumpiness to it, or some roughness or loose edges. So the other method is to use something like a Vuforia code or a QR code, where you can actually affix that to an object, and that will give you both very precise tracking and position, but also a recognizable location. So you can make a specific QR code correspond to a specific machine in the world, or a specific part of the car, and wherever that machine is, wherever that car drives, it will be recognized as that car, instead of just a blob of spatial mesh polygons that kind of roughly correspond to the car. So those are kind of the two key ways that you're going to anchor things to the world. Both of them are pretty accurate, down to millimeters and single degree precision, which sounds really great. One of the things that quickly you realize is there's sort of a called like the multiplied inaccuracy problem, right? That like if you have a QR code that's a couple inches across and it's like half a degree off, you're never going to see that. You're never going to notice the difference. But if you anchor, say, a 10-foot long pole and it's half a degree off, it's gonna be all raised 2 feet away from where it should be, right? So that distance of the length of the mesh kind of is multiplied against that little tiny bit of inaccuracy. And so you do end up with problems where if you try to detect a QR code at, say, on the hood of a car, by the time you walk to the back of the car, it's like a foot up in the air. So you can actually help adjust for that by adding multiple tracking codes on different parts of your device. So as you walk from one end of the car to the other, it's constantly readjusting based on new QR codes that it finds. Microsoft has a package called the World Locking Tools, or Frozen World, that helps with this kind of multiple tracking point problem. So not only do they kind of automatically adjust as new anchors are detected, it also handles weird quirks like what physics does. So if you have, say, a rope bridge, right, and it's anchored on 2 points, and then one end moves because its anchor position has been corrected, right? You don't want the whole bridge to, whoa, because one end didn't actually move. It was just its position was corrected based on the input. So those are World Locking Tools will help with that. This is a hard problem, and you're going to spend a significant amount of time trying to address it, but it is totally possible. You can do big, huge machines. You can anchor stuff, through a factory, and you walk through a big warehouse, and at each point you're kind of recorrecting, and that is a great way to learn about these things. You can also kind of work around the problem by saying, here's the real object, and here's a virtual reproduction of the object next to it, and in that proximity, it can be almost as useful as an overlay. So that's kind of question that's come up. Feel free to ask some more. I'm pulling these questions from highly upvoted questions on the questions tab. So if you want to go over there, upvote something you want to know about, I'll dig those out. Another really interesting question about HoloLens in the sunlight. This was one of my favorite things when the NDA dropped at Microsoft, is I got to take a HoloLens outside and be like, does this actually work outdoors? And if you know anything about computer vision or photography, you probably know that the sun is just incredibly bright, like 1,000, like 10,000, 100,000 times brighter than indoors. And our eyes are just so good at dilating and adjusting for that. We don't realize that like houses and indoor spaces are just incredibly dark. And it's like not comparable, but we adapt to it because humans are amazing that way. Technology, not so amazing. So the sensors, the cameras that are out-facing on the HoloLens actually are tuned for indoors, because that's primarily where HoloLenses are worn. There's nothing really special about outdoors. You could just tune the light sensors to be a little bit different. Basically sunglasses on your HoloLens cameras, and like very quickly, like day one out in the sun, I thought, could I put actual sunglasses over the tracking sensors on a HoloLens, and then the world will be dimmer and it will have an easier time? So maybe that's something to look into if you're a DIY kind of person. You could also, so one of the interesting things, Magic Leap 1 actually is the display is a lot more visible outdoors, because it blocks more of the light. So some people think Magic Leap is more vivid or gives better colors. The trade-off is it makes the world darker. It takes some color out of the real world part of the light that reaches your eye, and then you get better brightness, or better like observed brightness on a Magic Leap. So Magic Leaps, actually you can see the holograms more clearly outdoors, just because it has a higher light blocking ratio. So it also makes me wonder, if I put on sunglasses on the outside of my HoloLens, would that then make I'm pretty sure that would just make all of the holograms easier to see, right? Because there's less light from the sun like overblowing, like brightening out the waveguides in the HoloLens. So not really great for outdoors, but if you want to hack around and try some fun things, go ahead and do that. But better to do things indoors, or at least on a cloudy day. 2 questions about how much do XR developers get paid? How much do HoloLens developers get paid? In my experience, this is a super fast growing field. It's really easy to get a job if you have the XR development skills. The pay is significantly better than game development, which is sort of same skill set. It's probably not as good as something like going to work at Facebook or Google and just building Instagram or something. But these are still great jobs. You're going to have great pay, super competitive. So it's a ton of job security. You leave one place and immediately start somewhere else. So it's a great career to go into. Send your kids to college to become XR developers. Send them to CircuitStream. That's how they'll learn. Question about whether this whether MRTK works on Oculus Quest or Leap Motion. There is a Quest fork that you can today download and run on your Quest. It's totally the best way to experience weird hands interactions for like business applications and all the buttons and everything. So you can definitely grab that. There are some other forks that I think have Leap Motion support, and if they don't, then it's really pretty easy to add that kind of hardware support. All of the TK is built on top of a generic hand interface, and then you can create just a shim in the middle that translates Leap Motion or whatever hand tracking hardware you're using into that general interface, and then your application can run on any of those hardware. I've run MRTK on a bunch of different hand trackers, and it works great. And then, okay, here's another great question. Is there a faster way to run the project than having to build that other solution and then change the file and then, deploy that script and then get it on the device? So this is a perfect example of what I was talking about with iterate as much as you can, not on the device as quickly as possible. It's really important to find all the cool ways that you can get around the very long loop it takes to get onto the device. And I mean, this was a great example, right? Like Nikisa forgot to check a box and deployed the device, and it burned, 4 minutes. And then you check the box, and then you burn another 4 minutes. Like, you want to avoid that as much as possible. So, two really great tools for that are the input simulation service, which allows you to simulate hands and moving the HoloLens, and basically all of the onboard sensors can provide simulated data directly in Unity via your mouse and keyboard. So that's an incredibly powerful tool if you're trying to pose hands in a specific way to get your recognition algorithm to work. Use the input simulation service. You'll be iterating like that. You don't have to wait for all the build processes to happen. The other really great tool is the holographic remote package, and the way that works is it actually streams video directly from your Unity Play and Editor window to the HoloLens display over Wi-Fi. And so that's limited in that you don't get the same kind of like integrated communications. You don't have like spatial mesh, and so you can't do your app fully. But if you're trying to iterate on visual style and seeing the colors on the HoloLens display, or just what something looks like, or the scale of something around you, that is a really great way to, you just hit play and it's on the display on the headset, and you're iterating that fast. There are a lot of pitfalls around HoloLens displays. Like, there are weird colors, there's chromatic aberration, there's rainbowing. Like, if you've ever put on one of those devices, you know what I'm talking about. Like, it's just sort of the nature of the technology that it does not look like a computer screen, and it won't for many years to come. I think, okay, one more. Do I consider other AR glasses based on Android wildly different? I would say, yeah, like that's a totally different animal. Like, not even my unicorn. I really think there's only 3 devices in this category. It's the HoloLens, the Magic Leap 1s, and the HoloLens 2. Obviously, the HoloLens 1 is like 6 years ago's device, right? So the HoloLens 2 is way more advanced. Magic Leap 1 is pretty comparable to HoloLens 2, but I still think it's a close second. And every other device on the market that you can buy commercially is something that I would argue isn't even really AR. It's more like a heads-up display, because really, in my definition of AR, awareness of the world is a key piece of what makes AR, right? If you're not aware of the world, you can't integrate computing in the world. You can't augment reality. And so all these devices that, can maybe project 3D video for you and put something in the world, but aren't really aware of it intersecting the world or colliding the world, or don't have 6DoF tracking for your head, like that doesn't rise to what I would consider augmented reality. And things like, a smartphone AR video overlay. We're really in a different territory here than a head-mounted AR device. So really think there's only those 3 devices in the category, truly. So, all right, that's enough for my pre-prepared questions. Feel free to ask in chat or the questions tab, and Nikisa and I will answer whatever you ask.
So we are actually running to the 2-hour mark here. I know our recording stops.
I use them all
shortly.
I'm such a hog. I'm sorry,
it's
Nikisa.
all good. It's all good.
It's okay. People don't like my jokes, apparently.
But we will be collecting all of these questions and answering them in the next couple of days. Nikisa, Eric, thank you so much for joining me on this webinar workshop and leading that middle portion there. We will be wrapping up. I'm sorry, everyone, but we are going to get back to those questions. If there's something that we didn't get to, feel free to reach out to myself, to Kyle, to Dayon. We'll be more than happy to forward those questions to Nikisa and Eric. But do join us next week for our XR sound design workshop. That's August 27th. And thank you again, everyone, for joining us. Nikisa, Eric, thank you. It's a pleasure as always. Have a wonderful night, morning, evening for all of you still tuned in. And hopefully we'll see you again soon. Take care.
Bye.